Hi everybody. So today we're going to do a physics experiment, and it's going to be more fun than it seems, okay? Uh, so first, you're going to need two things. A chair like I'm sitting in, one that spins around, and you're going to need something kind of heavy to hold in your hands. It doesn't have to be super heavy, but something like two small weights or maybe two water bottles to hold in your hands, but just something to have some weight in your hands. Now, when you're doing this test, make sure you're being careful, okay? But it's pretty simple. All you're going to do is you're going to take those two weights, right? And then you're going to spin on the chair a little bit. And you don't have to go super fast, but then just stick your arms out. And you'll notice that you slow down. Pull the weights back in and you speed up. Put them out and you slow down. But if you pull them back in, you speed up again. So what's happening there? Well, when an object is spinning, it has something called angular momentum. Angular momentum remains constant while the object is spinning, unless an outside force, such as friction, comes in. If nothing else changes, the speed and direction of the spin will remain constant. So obviously, you eventually slow down when you spin around in a chair, but that's because there's friction from the air, from the parts of the chair that are making contact. So that's why you slow down. If it wasn't for the friction from those things, you would keep spinning and spinning and spinning forever. So angular momentum is made up of the speed of the spin, the radius of the spinning object, and the mass of the spinning object. So since the angular momentum is constant, if one of those things changes, then the other must also change to make up for it. So if the radius gets smaller, the speed must get faster to make up for it. This is what happens in the spinning chair. As you spin with your arms or legs out to the side, your radius is large. When you tuck your arms and legs in, it decreases your radius, so you speed up to keep your angular momentum the same. So that's a quick little physics experiment that you can do at home, and thank you all for watching.